Welcome to ZICA Academy YouTube channel. In this lecture, I want to provide solution to question on time series analysis. ICAN May 2024 performance management question number 4. If you are coming across my lecture for the first time, please make sure you like the video, share it with others, and subscribe so that you don't miss my upcoming videos. If you are a returning subscriber, I say thank you for being part of this channel. Some time ago, Robert launched a new product some years ago at first. Sales were good, but now the figures are causing concern. Robert wants a more accurate sales forecast to produce detailed cash forecast. Since there is some seasonality present in the raw data, the series for sales shown below represent the underlying trend based on an averaging process. We have year, quarter, trend point, sales in carton, trend point in X, Y, sales in carton denoted by Y. 2016, the third quarter of 2016, trend point is 1 and sales is 10,000. So fourth quarter of 2016, we have 10,790. 2017 first quarter, 10,920. 2017 second quarter, 11,000. 2017 third quarter, 11,050. 2017 fourth quarter, 11,080. 2018 first quarter, 11,085. 2018 second quarter, 11,095. 2018 fourth quarter, 11,130. On average, quarters 1 and 3 are 5% and 6% respectively above trend, while quarters 2 and 4 are respectively 2% and 9% below trend. Some preliminary calculations on the above 10 observations have been carried out, and the results are summarized below. We have results from 10 periods observations. Linear regression, we have y equal to e plus bx. The slope is 82.67. Intercepts is 10,472.33. Coefficient of determination is 0.535. It is required to make forecasts of sales for quarters 3 and 4 in 2019 and for quarters 1 and 2 in 2020. But there is some discussion on whether the 10 period data shown above are suitable for forecasting, or whether only the last 5 periods would provide a better basis for forecasting. Linear analysis of the last 5 periods only gives the following intermediate results. Results of last 5 periods observations, summation y 555.10, summation x squared 330, summation y squared 61,627.40, summation xy 4,442.15. Note, the y values have been scaled down by 100 times for ease of calculation required. Forecast the sales of the 4 quarters. 4 quarters required using the 10 periods observations result. B. Prepare similar forecast based on the last 5 periods observations. C. Explain which forecasting basis produce the better forecast. This question is obtained from ICAN May 2024 performance management question number 4. Let's have solution to the question. Solution. Back to the requirements. A. You are to forecast the sales of the 4 quarters required using the 10 period observation result. Sales of the 4 quarters. 4 quarters required. Now, what are the 4 quarters required? It is required to make forecast of sales of quarter 3 and 4 in 2019 and for quarters 1 and 2 in 2020. These are the required sales. So quarter 3 and quarter 4 of 2019 and quarter 1 and 2 of year 2020. Y equals to A plus BX. Now, the first thing is to estimate the trend in the data. So we want to estimate the trend in the data. So we want to estimate the trend in the data. So trend is Y equals to A. What is the value of A using 10 periods observations? The value of A is the intercepts, which is 10,472.33. So A is 10,472.33 plus B. B is the slope. B is the slope. And that slope is given to be 82.67. 82.67. Then we have X here. This is the trend line. That is the trend line. Remember, you want to make the forecast sales of the 3rd and 4th quarter in 2019. But if you look at the results given here, this is the last quarter, the 4th quarter of 2018, which is 10. If the 4th quarter of the year 2018 is 10, then quarter 1 of 2019, that will be 11. Quarter 2 of 2019, that will be 12. Quarter 3 of 2019, that will be 13. Quarter 4 or the 4th quarter of the year 2019, that will be 14. Then, remember, you are to estimate the sales for quarter 3 and 4 in 2019. And for quarter 1 and 2 in 2020. Quarter 3 and 4 of 2019. This is what is required. And first quarter of 2020. That will be 15. While the second quarter 2 of 2020, of year 2020, that will be 16. So, remember, the requirement is to estimate the sales for quarter 3 and 4 in 2019 and for quarter 1 and 2 in 2020. So, this is quarter 1 of 2020, this is quarter 2 of 2020. That means the sales required is for quarter 3 of 2019, and the value of X is 13. Quarter 4 of 2019, the value of X is 14. Quarter 1 of 2020, the value of X is 15. Quarter 2 of 2020, the value of X is 16. So we want to estimate the trend in the data. We have here Y equals to 10,472.33, then 472.33 plus 82.67x. 82.67x. So we have the year 2019, and you have to estimate sales for the 3rd quarter. So we have quarter 3. So, and the trend is Y equals to 10,472.33 plus 82.67 times X. The first quarter of 2019, the value of X is 13, multiplied by 13. So we have 13 times 82.67. We have 1,074.71 plus 10,472.33. So we have 11,547.04. 547.04. That is the trend for the third quarter of 2019. Then the fourth quarter of 2019, quarter 4, trend will be y equals to, we have 10,472.33 plus 82.67x. And our x for the fourth quarter of 2019, x is 14. 82.67 times 14, that gives us 1,157.38 plus 10,472.33. We have 11,629.71. Then the year 2020, the first quarter, we have y equals to 10,472.33 plus 82.67 times x. And the first quarter of 2015, the value of x is 15. 82.67 times 15, we have 1,240.05 plus 10,472.33. We have 11,712.38. Same year 2020, we have the second quarter of year 2020. So y equals to 10,472.33 plus 82.67 multiplied by x. And the value of x for second quarter of 2020 is 16. Multiplied by 16. 82.67 times 16. That gives us 1,322.72 plus 10,472.33. So we have 11,795.05. Now, back to the question. You are to forecast the sales of the 4 quarters required using the 10 periods observations result. Now, remember, this trend is subject to seasonal variation. So, now we adjust. Let's adjust for seasonal variation. Adjust for seasonal change. Remember, I've told you the time series data, time series value. If you have watched my earlier presentation, I said it's equal to trend times seasonal variation. That is, if you are using the multiplicative model. So if you are using multiplicative model, it will be T times S. And I told you that multiplicative model is appropriate where the seasonal variation is given in percentage or a decimal number. Now, we were told on average, quarter 1 and 3 are 5% and 6% respectively above trend, while quarter 2 and 4 are respectively 2% and 9% below trend. Now, we have year 2019. So, we have quarters. Then, in 2019, quarter 3. In 2019 again, quarter 4. In 2020, quarter 1. In 2020, quarter 2. Then, the sales forecast for quarter 3 of 2019 is 11,547.04. 11 seasonally adjusted sales. So we have 11,547.04, 547.04. That is the trend. Then for quarter 4, we have 11,629.71, 11,629.71. Then quarter 1 of 2020, 11,712.38, 11,712.38. Then quarter 2, 11,795.05, 11,795.05. Then these are the trend multiplied by seasonal percentage. You were told on average, quarter 1 and 3 are 5% and 6% respectively above trend. No, anytime percentage is involved, percentage means per 100. If it increase, you add the percentage increase to 100. If it decrease, you subtract the percentage decrease from 100. Since it is above trend, that means it increase. Quarter 1 is 5% above trend. Then you add 5 to 100, then you have 105. That is for quarter 1, 105%. 105% means divided by 100. 105 divided by 100, which is 1.05. Quarter 4, then the next one. No, that is for, sorry. It is quarter 1. Quarter 1 is 5% above trend. Where is quarter 1? We have quarter 1 in 2020. That is times 105%. And quarter 3 is 6% above trend. Quarter 3, we have it in 2019. Times 106%. Then, whilst quarter 2 and 4 are respectively 2% and 9% below trend. Since it is below trend, you subtract it from 100. That means quarter 2 now, if you subtract 2 from 100, you'll be left with 98%. That is for quarter 2. Quarter 2, we have it here. This is quarter 2 times 98%. And quarter 4, this is for quarter 4, below trend. You subtract 9 from 100. 100 minus 9, that will be 91%. We have quarter 4 in 2019. That's 91%. If you subtract 9 from 100, then you have 91. Then what will now be the seasonally adjusted sales? So 11,547.04 times 1.06. That's 106 divided by 100. That gives us 12,239.86. If you want to take it to nearest whole number, it will be 12,240. Then this one, 11,629, 11,629.71 times 91%. That's 91 divided by 100. So you have 10,583.30. 10,583.03. 04 approximately. Then 11,712.38 times 105%. We have 12,298.00. Then 11,795.04 times 98%. We have 11,559.14. This is the solution to A part of the question. You are to prepare the similar forecast based on the last 5 periods of observations. If you look at the information provided here, you are not given the trend line. So the trend line is usually given as y equal to a plus bx. And to estimate the value of b equals to n summation xy minus summation x summation y over n summation x squared minus summation x all in square. So the number of periods, since you are to use 5 periods, you have to prepare similar forecast based on the last 5 periods of observations. That means n is 5. You are given summation xy to be 4,442.15. N is 5. Since it is 5 periods of observations, n is 5 times summation xy. Summation xy is 4,442.15. 4,442.15 minus summation x. So if you look at the information provided, the data provided here, there is no summation x among. We only have summation x squared. So you go back to the initial data provided, the last 5 periods. Let's add it. 1, 2, 3, 4, 5. This is x. So you add the last 5. So now let's sum it up. 6 plus 7 plus 8 plus 9 plus 10. We have 40. So summation x equals to 40. So summation x equals to 40. So as calculated. Please take note of that. If summation x is 40, this is 40 multiplied by summation y. You are given summation y to be 555.10. 555.10. All over n remain 5 times summation x squared. Summation x squared is 330. 330 minus summation x all in square. Summation x remain 40 as determined earlier from here. So it remains 40. So we have 40 square. So 5 times 4,442.15. So we have 22,210.75 minus 40 times 555.10. That gives us 22,204 all over 5 times 330. We have 1,650 minus the square of 40 is 1,600. So now let's subtract the numerator. 22,210.75 minus 22,204. We have 6.75 over, to subtract 1,650 minus 16. Then you'll be left with 50. Therefore, B equals to, divided by 50, 0.135. Back to the regression line. Y equal to A plus BX. We know the value of B. Then we need the value of A. So A equal to summation Y over N minus B summation X over N. Summation Y remains 555.10. 555.10 over N, 5 periods observation, minus B, or B as determined or calculated, 0.135 times summation X. Summation X remain 40 as calculated earlier, over N, which is 5 periods. So 555.1 divided by 5. Then we have 111.02 minus 0.135 times 40 divided by 5. We have 1.08. If you subtract that, you have A equals to minus 111.02. Then you'll be left with 109.94. Note, the Y values have been scaled down by 100 times for ease of calculation. If the value of Y, if it has been scaled down by 100, that means the correct value of A will be 109.94 times 100. You now multiply by 100. Then you have 10,994. Then the value of B, which is 0.135, you also multiply that by 100. B 0.135 times 100. That gives us, we have 13.5. So the regression line will now be, you have Y equal to A plus BX. Let's substitute for A and B. So you have Y equals to A 10,994 plus B. B is 13.5. X. This is the regression line. So you now go back to estimate the value of sales for the 4 quarters as required. We can now estimate the trend in the data. Estimate the trend in the data. Estimate the trend in the data. So we have year, we have quarters, and the trend. So the trend line remains y equals to, trend line is y equals to, we got 10,994 plus 13.5x. 10,994 plus 13.5x. That is the trend line. So you want to estimate the sales for quarter 3 and quarter 4 of the year 2019, and the first quarter and second quarter in the year 2020. So we have 2019, quarter 3 and quarter 4. Then 2020, we have quarter 1 and quarter 2. Now, we want to estimate the value of y for each of the quarters. So we have y equals to 10,994 plus 13.5x. And our x for quarter 3 of the year 2019, we have x to be 13. So we have 13. So 13 times 13.5. 13 times 13.5. That gives us 175.5 plus 10,994. We have 11,169.50. Then for quarter 4 of the year 2019, y remains 10,994 plus 13.5x. In the quarter 4, for quarter 4 of the year 2019, quarter 4, we have the value of x to be 14. So if x is 14, that gives us 13.5 times 14. We have 189 plus 10,994. That gives us 11,183. Then quarter 1 of the year 2020, we have y equals to 10,994 plus 13.5 multiplied by x. Quarter 1 of 2020, the value of x equal to 15. We have 15. 13.5 times 15, that gives us 202.5 plus 10,994. That gives us 11,196.5. Then quarter 2 of the year 2020, we have y equals to 10,994 plus 13.5 multiplied by x. And the value of x for quarter 2 of the year 2020 is 16. So we have 16. 13.5 times 16, that gives us 216 plus 10,994. That is total 11,210. Then we now adjust our trend for seasonal variation. So adjust for seasonal variation, or you adjust for the seasonality. So remember, I've told you time series value equals to trend times seasonal variation using multiplicative model. Remember, I've told you that multiplicative model is most appropriate where the seasonal variation is or are given in percentages. So we have year, we have quarters. 2019, 2020, 2019, 2020, 2020. This is quarter 3, this is quarter 4, this is quarter 1, and this is quarter 2. Then adjusted sales or seasonally adjusted sales. We have 11,169.5. 11,169.5. Then we have 11,183. 11,183. Then we have 11,196.5. 11,196.5. Then we have 11,210. Now, what are the seasonal change? On average, quarters 1 and 3 are 5% and 6% respectively above trend. If it is 1 and 3, if they are above trend, I've told you percentage mean per 100. If it is above trend now, that means it is above 100. So you add 5% and 6% to 100%, giving us 105% and 106% for quarter 1 and 3. So in quarter 3, in quarter 1, that means you'll be having 105%. We have quarter 1 in the year 2020, 105%. Then, and quarter 3, which will be 106. We have quarter 3 in the year 2019, so 106%. Now, why is quarter 2 and 4 are respectively 2% and 9% below trend? If they are below trend, and percentage may per 100, and if they are below trend, then you subtract those percentages from 100%. Therefore, for quarter 2 now, you have, if you subtract 2% from 100%, you'll be left with 98%. That is for quarter 2. Quarter 2, we have that in the year 2020, 98%. Then, and quarter 4. So, if you remove 9% from 100%, you'll be left with 91%. 91%. Now, our seasonally adjusted sales will be 11,169.5 times 106%. No, it means you will need to divide the result by 100 times 106 divided by 100. So that gives us 11,840 approximately to nearest whole number. Then this one, 11,183 times 91%. That gives us 10,177 to the nearest whole number. Then 11,196 times 105%. That gives us 11,756. 756. Then the second quarter of the year 2020, 11,210 times 98%. That gives us 10,986. 986. D. Explain which forecasting basis produce the better forecast. So you want to explain the forecast basis that produce a better forecast. One of the best method of estimating the one that will produce a better result is by comparing the coefficient of determination of the results from 10 periods of observation with the results of the last 5 periods of observations. The coefficient of determination for the 10 period observation has been given, and that is given 10 periods observation. Coefficient of determination, which is R squared, and that is given to be 0.535. 0.535. That of the 5 periods of observation is not given. So you will need to estimate that. To estimate the coefficient of determination, you find the square of the product moment correlation coefficient. Remember, the formula for correlation coefficient is n summation s y minus summation x summation y over square root. But when you square it now, over square root of n summation s squared minus summation x all squared multiplied by n summation y squared minus summation y all squared. Then, if this is supposed to carry square root, but if you square it, the square root will disappear. Then the numerator will not carry square. So that means the r square will be this. So n, for 5 periods of observation, n is 5. 5 times summation xy. Summation xy is given to be 4,442.15. 4,442.15 minus summation x, which was calculated from our earlier solution, we got 40, times summation y. Summation y is 555.10. 555.10. Everything here we carry square. Over n, our n is 5. 5 times summation x squared. Summation x squared is 330 times 330 minus summation x. X is 40, so we have square into n remains 5 times summation y squared. Summation y squared, and that is given to be 61,627.40. 61,627.40. That is summation y squared minus summation y all squared. And summation y is given to be 555.10. 555.10 square. So 5 times 442.15. That gives us 22,210.75 minus 40 times 555.10. That gives us 22,204. All is square. All over 5 times 330. That gives us 1,650 minus square of 40. That is 1,600. 5 times 61,627.4. That gives us 308,137 minus 555.1 square. That gives us 308,136.01. So, what is the difference between this and this? This minus this. 22,210.75 minus 22,204. We have 6.75 square, the square here, over 1,650 minus 1,600. That will be 50 multiplied by 308,137 minus 308,136.01. We have 0.99. What is the square of 6.75? 6.75 square. That will be 45.5625 over 50 times 0.99. That gives us 49.5. 49.5. So, you divide 45.5625 divided by 49.5. That gives us 0.92. Therefore, R square is 0.92. This is the coefficient of determination for 5 period observations. Now, and the coefficient of determination for 10 period observation is given to be 0.535. 0.535. 5 periods observation is better than 10 period observation. We can say we have this is equivalent to 92%. And this is 53.5%. Can say using 5 period observation, you have 92% variation. And here you only have 53.5% variation. So 5 period observation is better. This marks the end of the solution to the question. Please drop the love emoji. Also share the video with others. Thanks for watching ZICA.